Hi, I'm Craig, and welcome back to Concrete 101. As you know, concrete is made by combining cementitious materials, water, and aggregates. It may also contain pigments and admixtures. Today we're going to go a little deeper into the cementitious materials, which include not only the cement, but also supplemental cementitious materials, or pozzolans. Pozzolans have been around for a long time, stretching way back to ancient civilizations. So what are pozzolans? Pozzolans are finely ground materials that have cementitious properties when combined with cement and water. By cementitious, we mean that under the right conditions, they get hard and gain strength like cement. Because of this, we can use pozzolans to replace some of the cement in our concrete mixes. The most common types of pozzolans that are used in concrete products are actually two waste materials, including fly ash, which comes from the coal burning process, and slag, which comes from the steel making process. Fly ash can be either Class C or Class F, depending on where the coal comes from. Class C is typically tan in color, while F is gray. Slag cement is very light in color and can be as white cement. Pozzolans are really a story of trash to treasures. So the word of the day is pozzolans. Now let's visit our superhero friend Recyclo, who will tell us more about the benefits of pozzolans and why we use them.
Hi there, it's your favorite superhero, Recyclo. And Recyclo is here today to talk to you about the word of the day, which is, that's right, pozzolans. So what is a pozzolan? Pozzolan is something that we use in our concrete to replace some of the cement. Now there's different types of pozzolans and we'll talk about them, but before we do that, Recyclo's got to don his safety gear because whenever you go into a plant, you always want to be wearing your safety gear. So, now, I see in your plant, you're using a product we call fly ash. Now, fly ash is a waste product generated by a coal-fired electric plant. Slag is actually a waste product that comes from steel production. So it's collected off, ground up, and again brought to your plant. So now let's talk about what these two products do in your concrete. So there's a couple of things. First off, it replaces some of the cement that you use, so you might be saving some money. Secondly, it may be a help for you to control efflorescence, which is that white stuff that nobody wants to see. A third thing is that it might help you with attaining colors that you normally couldn't get using cement alone. And we like to refer to recycled products, as you can see here, as a green product. So we're taking something that was a waste product and we're using it in a positive way in another product, which is always a good thing. So at the end of the day, keeping these things in mind, pozzolans can be a very big help to you in your concrete to make it a little bit less efflorescence producing, a little bit lighter colors, a little bit greener, and maybe a little bit lower cost as well.
So how do pozzolans work? Technically, a pozzolan is defined as follows: a silica-based material which in itself possesses little or no cementitious value. However, when finely divided, in other words, a powder, and in the presence of moisture or water, pozzolans chemically react with calcium hydroxide to produce compounds possessing cementitious properties. So let's unpack cementitious properties. As you learned last time, cement is a fine powder which reacts with water during the hydration process, forming long needles. The needles from the different cement particles grow together and harden into a rock-like substance called cement paste. And this binds all the aggregate particles together to form concrete. If we look at it in a bit more detail, cement is primarily made up of calcium silicates, and during the cement hydration process, the calcium silicates react with water to form what we call calcium silicate hydrate, or CSH gel. These are the long needles that grow together and harden, forming cement paste. It's called a gel because the needles are somewhat irregular in composition and don't have an exact crystal structure. Unfortunately, the cement hydration process is not completely efficient. Only about 75% of the cement forms the CSH gel, or the good glue. The other 25% forms a byproduct called calcium hydroxide, which chemically is CaOH2. So while the CSH gel is the good glue that holds the concrete together and has a major impact on the strength of the concrete, calcium hydroxide, on the other hand, is a small molecule that does not contribute to the strength. It's really a waste byproduct. Moreover, it is slightly soluble in water so that it can migrate or leach out of the manufactured concrete products and form white deposits called efflorescence on the surface. Okay, so now we know a bit more about the cement hydration reactions. How do pozzolans fit into the puzzle? We said before that pozzolans are not cement, but they act a bit like cement in the presence of calcium hydroxide in what is called a pozzolanic reaction. So what happens in the pozzolanic reaction? Let's break that down. First, as we said, if you mix pozzolans with water, you just get a wet mess. It does not harden and has no cementitious properties. But if we can find an activator, maybe we can get the pozzolan to react. And it turns out that calcium hydroxide is a very efficient activator for pozzolans. And if it is present when the pozzolan is mixed with water, then bingo presto, the combination will form CSH gel, or the good stuff. So where can we find some calcium hydroxide? Well, yep, it's right there in the cement hydration reaction. So when we replace some of the cement with pozzolan, we set up a virtuous cycle. Cement hydration produces a byproduct that can lead to efflorescence, and pozzolans can react with that byproduct to produce more good stuff, CSH gel, while reducing the potential for efflorescence. So if pozzolans have such magical powers, why doesn't everybody use them all the time? Well, that's because there's a trade-off. And the trade-off happens because the pozzolanic reaction is a fairly slow reaction that needs some heat and time to make it happen. Pozzolans need kiln temperatures of at least 85 degrees Fahrenheit or 30 degrees Celsius to react to any extent during the initial curing stages. It can also take a couple of weeks to months for the pozzolans to fully react during their storage in the yard. While pozzolans can help in the long term to reduce efflorescence, concrete products can actually be more prone to efflorescence during the initial curing period. This can be a problem for plants that don't add heat to their kilns, but depend solely on the heat of hydration of the cement. While this may be okay when temperatures inside the plant are over 70 degrees Fahrenheit or 21 degrees Celsius, it becomes a real issue when temperatures fall below 60 degrees Fahrenheit in the autumn, winter, or spring. In these situations, the concrete doesn't cure sufficiently, and the products can have low strength and be prone to chipping, cracking, and bad splits when they are taken out of the kiln. To eliminate this problem, a plant may need to reduce or eliminate the amount of pozzolan that they use in their mixes. Whatever you do, it's important that you keep the pozzolan content consistent all year long so that we maintain consistent product colors. This is especially true if the pozzolan is much lighter in color than cement.
It's a maintenance day in the paver plant, a maintenance day in the paver plant. Would you be mine? Could you be mine? Won't you be my paver? Hi there, boys and girls. It's Mr. Dodgers here, and welcome to my neighborhood. You know, Mr. Dodgers likes to change his shoes when he gets here into something more comfortable. So let's talk a little bit about our friends. We all have friends, and sometimes our friends have problems. So, oh, what do I hear there? I think it's someone at the door. I think the doorbell is ringing. I wonder who it could be. Oh, look at this, boys and girls. It's a letter to Mr. Dodgers. I wonder what's in the letter. Let's have a look. Dear Mr. Dodgers, we have a problem we are hoping you could help. We started using fly ash in our split-face colored architectural block this past summer and had no issues. Well, good for you. We really enjoyed the cost savings and the fact that we were making a green block. And you know, boys and girls, green means good for the environment. We noticed this November during a cold snap, we were getting a lot more chipping and breakage when we were splitting and packaging up those blocks as they came out of our big room curing. Do you know what might be going on, Mr. Dodgers? We could surely use your help. Many thanks, your friend, Wally Weebles. Well, Wally, we're sorry that you're having a problem, but it's okay to have a problem. Let's see if we can help in some ways. So sometimes the weather gets colder and you're having a problem with cracking and splitting problems, then it could be due to the fact that you're using a little too much fly ash. Because as the weather gets colder, and if you don't have good curing, something that adds heat, then there's a likelihood that the concrete doesn't get quite as strong as it would in the summertime. So a good answer might be to take out a little bit of the fly ash and add a little bit more cement. And that's something that you want to do year-round, girls and boys, because if you change the amount of fly ash in a mix, it's likely to change the color. So if you take out a little bit of the fly ash and add a little more of the cement, you will add some more strength and a little more heat, and that should help with the chipping and cracking problems, Mr. Weebles. So I'll be back next time. This is Mr. Dodgers.
So let's review what we've learned about pozzolans. Pozzolans are fine powders like fly ash and slag that are waste materials from other industries. While pozzolans don't react and get hard when mixed with water by themselves, when combined with cement, they do make more CSH gel, the good stuff, which increases the strength and durability of our products. When pozzolans are used to replace some of the cement, they make our products more environmentally friendly and greener because we're using up waste materials. And also because we're using less cement, we're releasing less carbon dioxide to the atmosphere. Pozzolans can help us make brighter colored concrete products because they're usually lighter in color than cement. In fact, slag is almost white in color and is especially helpful in making lighter colored products. Pozzolans can also reduce the cost of our products because they often cost less than the cement that they replace. This is especially true of fly ash. Finally, pozzolans can help us reduce efflorescence, which is the white deposits we sometimes see on the surface of our products. Finally, while pozzolans do give us lots of benefits, they do require some heat and time to react. So we need to be careful when using them in cool weather, especially if we're not adding any heat to our kilns. So that's it on pozzolans. Thanks for watching.
So that's all for today, folks, but feel free to check back with us anytime on our website, acmchem.com, where you can get more information and more videos on Concrete 101.